Hello guys, and welcome to my channel. Today I wanted us to look at this interesting concept in model development called General Additive Models. So this is an approach you take where you find linear and non-linear influences from your dependent or determining variables. It's the case where you add what we call splines to your variables, especially your non-linear variables, to support that influencing or that influential behavior. It organizes your model in an additive nature, and today we'll be looking at how to use that in RStudio on a dolphin behavioral dataset. So get with me and let's get started. So one of the first things we're going to do is just create a new script in RStudio. You do that with Control Shift N. Then we're going to be currently do a model pre-training, then enter into model development and evaluation. In short, we're going to add an extra step of how to deploy those models to AWS SageMaker. Alright. So to load our dependencies, we want to check for any missing packages or require packages that are missing from our installation. So the way you do that, you create an empty list, you assign all of these packages that you feel are required, then you check for whether any of those required packages are in our installed packages directory. And if it is in there, the next thing you do is to install those packages. So this is me creating that. Okay, now that install our packages, we want to use the library function to call those packages into a script, and then we start with pre-training. The important package we use there is the VGAM. That's the vectorized General Additive Model package in R. So now you include the part to your dataset, Dolphin dataset, and then call it. So what you see that we were dealing with a very small dataset with very small rows. We'll be exempting the ID, another irrelevant variable here, and then the variable we're trying to predict on is the behave variable. In our pre-training, we're going to set a seed to handle for randomness, and then split our data with the initial split function. We'll be making our training data a proportion of 80%. Then our training data, we're going to modify our behave, our target variable, to be a factor. We'll call that our test variable. Next, we'll move into model development. This is where we create a formula, a vectorized General Additive Model formula, which is simply, or it's also where you get to see how we use splines. Right, so we're going to say behave is a function of all of these other items, but because of the EDA that have been carried out, which is not shown here, you see that speed and distance are good candidates for splines because they are continuous numeric variables, and from our exploratory data analysis show non-linearity relationship with the behavior. Next, we're going to call our model with the VGAM model, passing our formula, the training data, and then our family is going to be cumulative. So that is where the additive nature of our model comes to show, right? Because it's cumulative, and you're going to see that in our model results. So we're going to run that. I had a few errors at first, and then I realized that with VGAM you'll have to pass in sm.ps instead of s for splines. So I made that change here, and then I run it again. We get a warning message which we're going to ignore, and then just check for the model summary. Right, from the model summary we're going to see very interesting metrics come out. In the logic link we're going to see the influence or the output of our cumulative function which we passed to the family. But interestingly, for the variables which we've assigned splines to, we see that we have a very significantly lower p-value on our speed over distance, indicating that speed is a more determining factor than distance. Our residual deviance is indicative of performance too. So the lower the residual deviance, the better. For the logic likelihood, the higher that value, the better. So we can just treat this as a baseline model and compare it with more fine-tuned, more generalized models that we may build in the future. Alright, so that's that for model development and interpreting the results. Other metrics are available here. But let's move on to how to deploy this model. So let's say we've got this model and would like to share it with other team members and move it into some staging, then production environment. We're going to need packages like Ventiva and Pins. We're not going to see all of that happen here, but this is a good foundation to learn how to deploy. So what you do is you go on SageMaker and AWS, create an identifier, then come on your local environment, pass in your model and give it a name, then pass that model to what you already have, SageMaker. Obviously, you're going to require some credentials to do this, but when you've got that, you can then establish an endpoint, and then using the predict function, take from your training set or from new data and then make predictions, and then you can see the output from here. For the model deployment part, this is an excerpt from Julia Silge's work on the matter. And that brings us to the end of using generalized additive models, especially in R and RStudio, and it should serve as a foundation for building more cool stuff like this. So let me know what you think. Some link in the description to help you out if you're just starting, and hey, let's go build something cool today.